You changed the prompt, you ran it a few times, it seems better. Seems. That word is doing an enormous amount of load-bearing work, and it is the reason most agent projects plateau, not because people can't improve them, but because they can't tell whether they did. This is the last lesson in the series, and it's the one that makes the other 4 measurable. Here's the loop almost everyone is in. You change something, the prompt, the tool description, the model. You run it once or twice. It looks better, so you keep the change and move on. Then on Thursday, on a slightly different task, the old problem is back, and you have no idea whether Monday's change helped, hurt, or did nothing at all. 2 runs of a non-deterministic system is not evidence. It's a coin landing heads twice. And you have been building on top of those coin flips for months. And I want to be fair before prescribing anything. This is genuinely hard, harder than testing normal software. The same input gives you different outputs. There's rarely one correct answer you can diff against. And an agent can arrive at exactly the right result through a completely stupid path, which will bite you the next time the task shifts slightly. So I understand why people skip it, but skipping it means every improvement you make is unverified, and unverified improvements accumulate into a system nobody can reason about. Here's the mistake that makes most first attempts useless. You grade the final answer. Did it get it right? Yes or no? Look at this run. It read 14 files it didn't need, searched the wrong directory, retried 4 times, and stumbled onto the answer. Graded on output alone, it passes. It burned 40,000 tokens, took 9 minutes, and got there essentially by luck. Score enough runs like that and you'll conclude your agent is fine, right up until a task where luck doesn't hold. So the shift that makes evaluation work. Grade the trajectory, not just the destination. What the agent did turns out to be far more predictive of future behavior than what it produced this time. And that gives you a much better read on where you stand. A clean path that fails at the last step is usually a small fix. A messy path that succeeds is a failure you simply haven't met yet. And if you only score outcomes, you have no way to tell those 2 apart. 4 levels, and you should build them in this order. 1. Did it finish? Completed, gave up, or ran forever? This is trivially cheap and it catches an embarrassing amount. 2. Was it right? Did the answer hold? Did the change actually work? 3. How did it get there? Which tools? How many retries? How many wrong turns? This is the trajectory, and it's where the signal lives. 4. What did it cost? In tokens and wall time and calls. Level 1 is free, and most teams don't even have that. Don't design the perfect framework. Go add level 1 this week. Now, the test set, and this is where people over-engineer. 20 real cases beat 200 generated ones, and it isn't close. Synthetic cases are drawn from what you imagine the agent would face. Your actual failures are drawn from what it really faced, and those are different distributions. Only one of them predicts anything, which means the test set writes itself, for free. Every time the agent does something wrong, that run becomes a case. Save the input, write down what should have happened, move on. 10 cases that genuinely surprised you is already a real eval suite. That's the bar. Start there today, not with a framework. 3 kinds of judge, and the order matters. Code. Did the test suite pass? Does the file exist? Is the JSON valid, was the tool called. Cheap, exact, and it never drifts. Limited to things with a definite answer, which is far more of your eval than people assume. A model. Is this summary faithful? Was the tone right? Did it follow the constraint? Scales well, fuzzy, and it needs checking of its own. You. Is this actually any good? Slow, irreplaceable, and to be spent carefully. Reach for them in that order. Every check you can push down into code is a check that never drifts and never costs you again. If you use a model as judge, and you probably should for some of it, there are 2 failure modes, and both are quiet. The first, it agrees with itself. A model grading output from the same family tends to like what it sees. Verbose, confident, nicely formatted answers score well whether or not they're correct, which is exactly the bias you were trying to escape. The second is worse. You start optimizing for the judge. Push on any metric long enough, and you get an agent that scores beautifully and helps nobody. The defense is cheap. Every so often, grade a handful yourself and compare. If the judge is drifting from your opinion, it's measuring the wrong thing, and that's a bug in your eval, not in your agent. And here's the real payoff, which isn't the score. Every fix you make to an agent is a change to a system with no type checker and no compiler. The tool description you sharpened to fix one case has quietly changed behavior on 9 others, and nothing anywhere will tell you. Without a sweep, you find out from a user, weeks later, on the case you cared most about. With one, you find out in 90 seconds before you commit. That's the whole return on this, and it's why even 10 cases pays for itself almost immediately. The cycle you're aiming for is unglamorous. Change one thing. Run the set. Compare against the last run. Keep it or revert it. One thing at a time. Genuinely change 2 and watch a number move, and you've learned nothing about which one moved it. This is the discipline people skip because it feels slow, and it is the reason their agent stops improving. And keep the numbers somewhere with history. A score with nothing to compare it against isn't a measurement, it's a number. So here is the minimum that actually works, and I want to be concrete because this is where people stall out shopping for tools. A folder of 20 saved inputs from real failures, a file saying what should happen in each, a script that runs all 20 and writes 1 row per case, a CSV with the date, the case, whether it finished, whether it was right, and what it cost. That is a complete evaluation system. No framework, no platform, no vendor. It's an afternoon of work, and it will outlive 3 rewrites of your agent. Buy something later if you outgrow it. You probably won't. When should you start? The first time you fixed something and weren't quite sure it stayed fixed. For almost everyone watching, that moment has already happened, probably more than once. And today is the cheapest it will ever be to begin. Your test set is your last 10 bad runs, and they're still sitting in your terminal history. Every week you wait, some of those scroll away. The line to keep. Evals are unit tests for a system that gives a different answer every time. And that reframing matters because you are not trying to prove your agent correct. You can't, and chasing that is why people never start. You are trying to notice when it changes. That's a far lower bar than the one people set for themselves, and it is the one that actually pays. 2 caveats, honestly. First, some work has no gradable answer. Open-ended writing, research, judgment calls. There's no assertion to write. For those, level 1 and level 4 still work, and human spot checks carry the rest. Partial measurement beats no measurement, and people abandon the whole idea because they can't measure everything. Second, test sets go stale. The cases that broke you in March are the ones you've since fixed, so they stop discriminating between good and bad versions. Keep adding new failures as they happen, and let old cases retire once they've passed for months. 3 steps this week. 1. Save your last 10 bad runs as cases. The input and 1 line on what should have happened. Nothing else. Resist building a schema. 2. Write the script that runs all 10 and records 3 columns. Finished, correct, tokens. 3. Run it before and after your next change. That one comparison already puts you ahead of most team shipping agents. And since this is the last of the 5, here they are in one place. The context window is working memory, and you are the one allocating it. Nothing is ever remembered. There's only a document that gets reread, and compaction quietly paraphrases your rules. Tool calling is a shape the model writes and your code honors. And almost every failure that looks like a bad model is a context that couldn't support a better call. Evals are how you find out whether any of that actually worked. 4 lessons of mechanism and 1 of measurement. That's the whole toolkit. So the last thing, you cannot improve what you can only describe. It feels better is a description, and you have been running on descriptions. 10 cases and 3 columns is the entire barrier to entry. It is genuinely that small, and it is the difference between an agent that gets better and one that just gets changed. Stop asking whether it feels better. Go and find out. And that's the series. 5 lessons, and underneath all of them was one idea. Look at what the model is looking at. Nearly everything else follows from that.